Hello students, in this video I am going to solve numerical from chapter 11 electricity class 10 science. Let's start with the numerical. So the given question is judge the equivalent resistance when the following are connected in parallel. So here we have two questions or two conditions. So in A case or A condition there are two resistors 1 ohm and 10 raised to 6 ohm. And in second case we have three resistors 1 ohm, 10 raised to 3 ohm and 10 raised to 6 ohm, and these both the condition we are going to connect this resistor in parallel. We have to judge the equivalent resistance. So we will start with first one, that is I'll write for this case 1. So the resistors given are, so first we will write down given. So given what we have two resistors. R1 is equals to 1 ohm and R2 is equals to 10 raised to 6 ohm. So these are the resistors which are given, and we have to find out equivalent resistance in case of parallel combination. So what is the formula in parallel combination to find out equivalent resistance? So I'll write it here. R1 divided by R equivalent is equals to 1 divided by R1 plus 1 divided by R2, and this continues if you have more resistors. Now we'll substitute the value. So I'll write here, substitute the values. Now 1 divided by equivalent resistance is equals to 1 divided by 1 plus 1 divided by 10 raised to 6. Now solve this. R equivalent is equals to 1 divided by 1 as it is, plus here it will be 1 with how many? 6 zeros. 1, 2, 3, 4, 5, 6. And this, if you take it on the numerical, see here, if you take this on a numerical, then there will be a decimal which we have to write in this number. So it becomes 1 divided by R equivalent is equals to 1 plus 0.1234, and 1. So here I have divided 1 by this denominator number. Now what we'll do? We will add these two. So 1 divided by R equivalent is equals to, we are going to get 1.1234, and 6. So see here. Now here this is the value of 1 divided by R equivalent. We want to find out only R equivalent or equivalent resistance. So it will become 1 divided by 1.000001. And when we divide 1 by this number, we are going to get 0.99 and 9, and it continues. How we are going to get this value? So you can see here. So this is our number, and we are going to divide it by 1. Now we cannot divide it directly for 1, so we will take it here 0. So 0. So if you multiply with the 9, then here we will get 9. Then if you minus, you will get 1. Another 0 you can take. Again by 9, you will get 9. Then again minus 1, 0. And again by 9, you will get 9. And like this, it continues. So the answer is 0.999. And this is our R equivalent or equivalent resistance in case of first case. That is A. Now we will see the second one, that is B. So I'll write it here, B case 2. Now here also first we will write what all given. So I'll write given R1 is 1 ohm, R2 is 10 raised to 3 ohm. Here we have 3 resistance. So R3 is 10 raised to 6 ohm. So we have total 3 resistors, and we have to find out the equivalent resistance in parallel combination. So again I'll write R equivalent is equals to question mark, and here we are going to connect it in a parallel, so I'll write parallel. So this is done. Now we know the formula. The formula is 1 by R equivalent is equals to 1 divided by R1 plus 1 divided by R2, and now we have 3 resistors, so we will write 1 divided by R3 also. And now substitute the values. So when we substitute the values, we are going to get R equivalent is equals to R1 is how much? 1 plus R2 is how much? 10 raised to 3 plus R3 is how much? 10 raised to 6. Now we will write it once again 1 by 1 plus 1 10 raised to 3 means what? 3 zeros on 1 plus 10 raised to 6 means what? 6 zeros on 1. So like this. Now shift these 1000 numbers. So when we shift these numbers on the numerator, we are going to get R equivalent is equals to 1 plus 0.001 plus 0.000001. So now we have to add these all the numbers. So therefore let me add it here. So 0.001, 0.000001, and then 1.00. Whatever zero you want, you can take it. Now see, we are going to get 1, 0, 0, 1, 0, 0, point, and 1. So this is the value which you are going to get it here. So write down the value. 1 by R equivalent is equals to 1.001001. But see, this is the value of 1 divided by R equivalent. I'll write it once again. 1 divided by R equivalent value is 1.001001. But we want only R equivalent. So now we will do it. Reciprocal it 1.001001. And now we are going to divide this 1 by this whole number. So what we can do it, now we cannot divide for 1 directly, so we will take it 0, so here it will be decimal. So 9 za, it will be 9, and then we are going to get again 1, so we will take one more 0, again 9 za, you will get 9, then 1 0, again 9 za, will get 9, and this division continues. So our answer for this is R equivalent is equals to 0.9 9 and 9 4. So this is the answer in case of case 2. So when we connect 3 or more resistors together, the resistor which has lesser resistance, see here R1 has lesser resistance, that is 1 ohm. So this will be near to our equivalent resistance, or we can say whenever we connect more resistance of different value of resistance in a parallel, equivalent resistance value will be always near to the resistance which has lower resistance. This is the conclusion. I hope you are understanding what I am telling. So I'll repeat once again. Whenever we connect more resistors in parallel, equivalent resistance will be always nearby the resistance which has lower resistance. So this is the answer for this first numerical. I hope you'll understand this solution. So if you like my videos, share my videos with your friends, and please consider subscribing my channel. If you have any doubts, comment those doubts in the video so that I'll solve it and I'll prepare a separate video for that. Thank you so much.